My name is Mohammed.
Hey class, this is Paul.
And we finally got a project done today, and we're going to show you how it works.
All right. So the way how our project works is technically we have 10 LEDs and 10 photoresistors. We have PA 0, 1, 2, 3, PE 12, 13, 14, and then 15 right here. That's total of 8 bits. We're gonna send 8 bits, receive 8 bits 4 times. That's 32 bits. The way how it works is first, our program is going to retrieve first 8 bit, and once it retrieves it, it's going to light up the LED according to that 8 bits, and then light up this light right here saying, hey, it's sending, and then trigger a photoresistor of an interrupt on this STM, and then that interrupt is going to receive and then light up LED right here saying, hey, I received it. Send the next one to trigger another interrupt for this STM, and then it will increment the address by 1 and then send and receive back and forth for 4 times.
All right. So now we have the transmitter right here. We're going to show you how it works.
So the way how a transmitter works is obviously we used, one second. Here's the data right here. We used this data and an assembly file called transmit.s right here. So the main is going to retrieve that data, and then it's going to send. And as you can see right here, we use the LED header, systig header, and the interrupt header as well. We're going to show you how in slow motion. As you can see right here, we use a delay of 1000, which is 1 second. But for we actually got it down to 9 milliseconds to transfer over 8-bit. So at first, we're going to transfer over this data right here for 1 second. And then later on, we're going to show you how it runs at 9 milliseconds.
All right. And now we're going to show you the receiver end right here. It's similar to the transmitter we have. Again, we used the main file right here. Right, and then we received using this .s file. We use a delay of 1000 milliseconds, which is 1 second, and then we got it down to 9 milliseconds.
All right, as you can see, we already got it debugging. No gimmicks. LEDs are all off, and right now the receiver is on a standby right now. So I'm gonna go ahead and click on play. Going in 3, 2, 1. As you can see, the light is blinking, and it's on 1 second interval.
Okay, that was the end of the 4 bytes.
Yep, that was the end of the 4 bytes. So let's check what's in our register, R0. And voila, R0 has hex value of 7F014423. And let's see what Mohammed has.
All right, same thing. I have the same values, 7F014423.
All right.
Transmit is next. All
right, now we're going to show you how fast it goes with the same data. I mean, different data, that is, which is, in a sec, 1 second. All right, now is our time to see how fast this thing can go. We got it down, as you can see right here, delay 9 milliseconds. So we're gonna send in a different data this time. It's 8F50AF5B. We already got it to debug right here. All right.
All right, and then in the receiver, again, have 9 milliseconds. Should be receiving the same data. R0 Sure, nothing on R0 at this moment.
All right, are you ready?
Are you ready?
All
All right.
All right.
3, 2, 1.
Go with
All right.
That was
That's
fast.
super fast.
All right.
Now let's check.
So let's see what's in the registers R0. It's 8F50AF5B.
That's the transmitter. Now on to
Mohammed's.
already. Same.
8F50AF5B. Fortunately, Mohammed has a Samsung phone which has a super slow motion video recording. So what we're gonna do is we're gonna slow motion film the 9 millisecond, and then we're gonna extract all the frames. It has 480 frames per second. It's gonna extract everything to start to the end where this light blinks, and that will show us the accurate time of how fast it transferred over. So good luck with everybody, and bye.
All right, peace out. Bye.
Hello, this is Paul. So the previous video that you just watched was actually the super slow motion video that was recorded by Mohammed. Now that file, I've actually opened it up on this program called the Virtual Dub. This program actually opens up that file, video file, and shows all the frames that are actually inside that video file. So as you can see, right there, 0. And if we scroll all the way to the end, 251. Meaning that slow motion video file that was recorded has total of 255 frames. Now the video was taken at a super slow motion rate, which is 480 frames per second. So if I scroll this, as you can see the scroll bar right here, all the way to 125. 120. This is the 125 frame 125, and frame 126 right here. You can see that the LED lights up. So because there's all this GPIO configuration, and the clock runs at roughly, the clock runs at 4 megahertz. We are going to start. We're gonna mark this frame right here, 125. So as we go scroll through the frames, you can see that this lights up, and once this lights up, this LED is gonna light up, that red one right there. And when this lights up, it's going to trigger the interrupt on the receiver, and then after it saves it, it's going to, after it saves it, it's going to light up this LED right here. Meaning, hey, it's already saved, so send in the next batch of 8-bit, and this LED will stay lit up for 9 milliseconds. So once that goes off, you can see that the next 8-bit of LED has changed. So 1111, that's F. 0101, that's technically I think that's A. So anyway, so we're gonna go. So that's the second byte, third byte, and then here's the fourth byte right here. So it lights up right here, and once this lights up, you can see that this one lights up. And this light right here is technically the indication of saying, hey, it's already, I saved it, so send in the next one. But on the after the fourth byte, there is no, there's only 32 bits, 4 bytes is actually 32 bits. So there's technically no data to be sent. But like I said, this is actually frame 188. So like I said, because there are all those configuration and initiation, we're just gonna find the frame. We're just gonna stop at the frame that shows where the light goes off. So this is frame 190 and this is frame 191. So technically, the speed is technically, the time it takes for this program to turn on, transfer, and then finish. So we're going to approximately calculate this. Frame 191 minus 125. That's actually 66 frames. Now, like I said, there are 480 frames per second on this super slow motion video that we took. So 66 divided by 480, that is 0.1375 seconds, which is 137.5 milliseconds. Thank you. Hope you enjoyed this video and see you in class. Bye bye.